we're just going to do 6. Alright, how many signals would you expect in the H-Nmr spectrum of this molecule, right? So how many unique hydrogens are there in this molecule? So we have 1, 2, 3, 4 hydrogens, right? We can see that hydrogen 1, we'll call this hydrogen A, is bonded to this oxygen. And we can also see that these hydrogens, they are bonded to that oxygen, right? So they both have the same environment, so they're going to both be A. Now we look at the middle. The middle is the same too, right? Because we have 2, right? B, we'll call it, is bonded to this oxygen and bonded to another CH2 group, right? Now if we look at 3, it's also going to be B because it's bonded to this CH2 group and this oxygen, the same environment as 2, right? So they're both in B's, right? So we have A and B, 2 of each. So that means we have 2 unique signals. Alright, 7. How many signals would you expect in the H-Nmr spectrum of the following compound, right? So how many unique hydrogens are there going to be? Well, we have 1 right here, right? So this is 1. We'll call this one A. Move down. So this carbon has no hydrogens, right? Because it has 4 bonds. So we can ignore that one. Same thing with right here. 4 bonds. 1, 2, 3, 4. No hydrogens. This one only has 3 bonds, which means it's got a hydrogen right there. And same for this side. It's got a hydrogen right there. Now, down here, we also have 1, 2, 3. So it's got a hydrogen right here. And right here, we get another one. Hydrogen right there, only 3 bonds. Right here, 4 bonds, no hydrogen. Here we have 2 bonds, so 2 hydrogens. And right here, oops, this is a C, if I can actually write what I want, CH3 group. So you have 3 hydrogens. So I'm just going to do it in green so it's a little easier to follow along. So this one is unique, only one connected to an oxygen, A. No hydrogens, no hydrogens. Alright, so this hydrogen is unique from the one connected to the oxygen, so we're going to call it B. If we go exactly over to the other side, we're going to call that one B2 because it's got the same environment. This one down here, right, we're going to call C because it's a different environment than the other 2 B's, and the A, obviously. Right down here, we got D, same reason, different environment, right, because here you're going to have this ethyl group playing a little bit of influence on it. Alright, then down here we got 2 hydrogens. We're going to call E, different environment from the benzyl hydrogens and the alcohol group. And then here we're going to call this one F because it is different than all of them, right? This is the only CH3 group. It's completely different environment than all of the other ones. So we got 1, 2, 3, 4, 5, 6, 7. So the answer is D. 7 signals on the H-Nmr. 8, right? How many signals would you expect to find on the H-Nmr spectrum of the following compound, right? So, first thing we see, there is symmetry here, right? If I fold this molecule in half, it's symmetrical. So, we can take that to our advantage. We'll use red, so it shows up a little bit better in contrast to that green. So we can start on this side. We got A right? This is CH3, this is CH2, that's different from CH3, so it's B. The oxygen, no hydrogens there. There are 4 bonds here, 1, 2, 3, 4, so no hydrogens. There are 3 bonds here, so there is a hydrogen, and that is different from either the CH2 or CH3 group, right? Sorry. So this is going to be C, and up here, we also have another hydrogen, right? And this is going to be C2, because it actually it won't be, it will be D. What? No, it won't. It'll be C. Sorry, I second guessed myself. That will be C. Now, because we know it's symmetrical, this side is just going to be the same as that side, right? Because it's symmetrical. So we know there's only 3 signals. So how many would you expect? 3 H-Nmr signals.